The next section is on arithmetic. We've seen an overview. Now we're going back and building up the basics with hopefully clear descriptions so that you can confidently start building things yourself. And although the lower level pieces here are not exciting, I hope with the introduction of at least the general program, we can see that we're heading for something larger, although even that program wasn't very elaborate. We will certainly do more interesting things as we develop more skills here. We're doing arithmetic not because it's particularly exciting, but because the symbolism should be familiar. There's the least jolt, if you will. And we could write programs, of course, but we've seen that there's a fair amount of overhead with writing a program. For testing just little bits, there's another alternative. The Mono system that you should have installed has a program C#. That's C, letter C with the word sharp. Let's try it out. Now I'm on a Windows machine and illustrate how I can do this. On the Windows machine, I need to open a special kind of terminal or console window. And one way to find it is by typing in mono after I typed the start key. And then you see mono command prompt. Unfortunately, I need this particular one. Doesn't really matter where we are in the system here. All I want to do is start C#. By the way, this would look pretty much the same if you were on a Mac. On a Mac, you can just open a terminal and automatically C# and the mono stuff should work. So here we are. This is the prompt looking for the user to enter stuff. And C# will allow you to enter statements one at a time and immediately act on them in C#. So it's unlike the compiler. This is an interpreter. Also, it extends the C# notation to allow you to enter an expression. And that's what we're going to do now. Like for arithmetic, I can enter 3 plus 7. And one thing is, even if it's an expression, C# requires it to look like a statement. The semicolon indicates the end of what you're entering. That's always required. So let's see what we get. And you'll notice that with no indentation here, it gives you back 10. What it does is it evaluates an expression and then displays the result. And if we're going to talk about arithmetic, this is definitely handy. We can also do subtraction. 12 minus 7. And here let me just illustrate. This is not line oriented. The semicolon is important to indicate the end of what you're doing. And I often forget it. Let's see what happens. Notice I get another prompt here indicating I can't be done, and oh yeah, I need a semicolon. And of course, 12 minus 7 is 5. As we discussed earlier, around an operator like the minus sign here, the space is not important. I could do 6 minus 2 with no space and semicolon, and that also works. And we've mentioned that you cannot do implicit multiplication. This would be legal in regular math. But when you do something that isn't legal, sometimes it has a hard time figuring out what to tell you. Semicolon. This doesn't make a lot of sense. And unfortunately, that's sometimes true when you make an error. If we, on the other hand, put in the asterisks for the multiplication, semicolon, we get our 40. Let's enter 7 plus 3 times 5, semicolon. Think what that should produce. If you say 7 plus 3 is 10 times 5 is 50, you're wrong. Why? Because C# inherits the normal precedence of arithmetic, which says you do multiplications before addition. And hence, we have 15 added to 7 is, in fact, 22. Of course, we can use parentheses also to force different things to be done first. And so in this case, we will get our 50 because we forced the 7 plus 3 first before multiplying by 5. I set division in a different section because it's more complicated. Let's have a look. Now, I can do something like 14.0 slash is for division, let's say 4.0 semicolon, and we get 3.5, and that's certainly what you'd expect. But let's suppose I shift this and write 14 slash 4, again the division sign, semicolon. What happens? 3. That looks pretty strange. But if you think about it, it's not, in one respect. When you first did division, way back in grade school, you probably just did it with integers. And you would say something like 14 divided by 4 is 3 here with a remainder of 2. So actually this 3 looks like part of the answer. It's the integer quotient that you would have from grade school. How does C# distinguish here? We've mentioned that numbers with decimal points here before are doubles. Because everything has a type in C#, we've already seen that plus does different things in different circumstances. The same is true with division, but here it's more subtle because we have obviously numbers with, that correspond to similar ideas in math, 14.0 and 14. But they are in fact different types in C#. The 14.0 is a double. It's our representation of a real number. And 14 without a decimal point is just an integer, or the C# name is the short int. That's a different data type. And when it works on two integers, it does integer division. Whereas when it has at least one double here, it attempts to give as best a decimal answer as it can. It turns out, we'll discuss this more later under different types, but double arithmetic is not done exactly. I mean, you should be aware that if I do 1 divided by 3.0 to make sure there's a double in here, I get a limited amount of accuracy, and of course it's not exactly right. You shouldn't depend on float arithmetic to be exact. Whereas integer arithmetic has its own issues we'll see later, but with small numbers like this it is exact. We still have another issue. Remember, going back to grade school, 14 divided by 4 was 3 with a remainder of 2. We only have part of our answer from the grade school version of division. Basically, there were two parts to the answer, the integer quotient and the remainder. What C# and many other languages do is come up with a different operator to give you the remainder. And since this is not standard in math, sometimes mod from modulus is used in math, but there's no standard one-character symbol. They grab one. So let's look at 14% sign 4 and semicolon. the percent sign here is grabbed to mean take the remainder. Remember, 14 divided by 4 was 3 with a remainder of 2. This gives you the other part of the integer division. It turns out that this remainder operation is more useful than you might think. You need to remember that strange symbol for this part of integer division, percent sign for the remainder. And again, that works if both of the operands here to this percent operator are both of type int. And so when they're just literal numbers, that means with no decimal point. Now, I do suggest that you follow the notes and try for yourself in C#, writing down but not hitting return, thinking what should the answer be, and checking. Let's try some different ones. For instance, what would 17/3 be? Note, they are both ints, so this should give an integer result. What's the integer part? 5. By the way, if you want the remainder, we can use the percent sign, and you would get 5 with a remainder of 2. On the other hand, if we have 2/3, which just looks like a very simple fraction, oops, integer division, 2 is smaller than 3, quotient is 0, but 2.0 divided by 3 is something that gives you approximately 2/3. We haven't given everything there is to say about numerical types here. You can look later in this chapter for more information under value types and conversion. We'll also talk more about C# later. Here's a link to the later section. We mentioned that the operators follow the precedence of math, but of course this percent one is a new one. So you need to note that the precedence of the percent operator, that is the remainder operator, is the same as for division and multiplication, because it's related to division, it makes sense, and hence, according to normal mathematical precedence, has higher precedence than addition and subtraction. Also recall that if you have several operations at the same precedence level, like 10 minus 3 plus 2, this is done from left to right. So it's 10 minus 3 is 7, plus 2 is 9. Onward. Now we're going to play some more with C# and add concepts of variables and assignment.